Hey guys, welcome back to Think Making. This is Anton and today I'll show you how to use analog signals in an Arduino. In the last video, you learned how to use digital signals in an Arduino. You also learned that a digital signal could only be high or low voltage, meaning it could only turn things fully on or fully off. Analog signals, on the other hand, represent an infinite range of values. This is useful to get accurate measurements or inputs from our environment. Yet, there are limitations. An Arduino is not powerful enough to process an infinite amount of data. Therefore, it has a 10-bit analog to digital converter, which reduces the analog signal to values between 0 and 1023, which represent a voltage range from 0 volts to 5 volts. This means that analog inputs will be a value between 1 and 1023. But it's not the same story when trying to write or output an analog signal. The problem is an Arduino can't actually output a true analog signal. Instead, when prompted to output an analog signal, it will output a PWM signal, which tries to simulate an analog signal. This PWM signal has a range between 0 and 255, 0 being 0 volts and 255 being 5 volts. There will be another video explaining how PWM works. But what's important to know is that PWM signals, aka fake analog signals, can only be sent out through the designated PWM pins in the Arduino board. These are marked by a tilde symbol. To demonstrate how analog signals work in an Arduino, we are wiring a simple circuit that will dim or brighten an LED depending on the ambient light's intensity. This intensity is an analog value, and to measure it, we're going to use a photoresistor. In case you need it, the bill of materials will be down in the description, as well as a Dropbox link with the circuit diagram and the sketch used. So let's start off with what you'll need: an Arduino board, a USB cable, a breadboard, some jumper wires, a small LED, a photoresistor, and 2 resistors around 200 ohms. If you've got everything, let's start making all the connections. First, connect the Arduino's 5V pin to the breadboard's positive line, and the Arduino's ground pin to the breadboard's negative line. Then, insert an LED to the breadboard. Connect its longer side to digital pin 11 using a wire, and its shorter side to the breadboard's negative line using a resistor. Then, insert a photoresistor to the breadboard. Connect one of its pins to the positive line in the breadboard using a wire, and its opposite pin to the breadboard's negative line using a resistor. Finally, connect that same pin of the photoresistor to the Arduino's analog pin 0 using a wire. See, it's quite simple. Now, we need a sketch that will make this circuit work. So go ahead and open the sketch I provided in the Dropbox link. So let's analyze how this code will work. First, 4 variables are set: LED pin with a value of 11, sensor pin with a value of A0, sensor value with a value of 0, and mapped value with a value of 0. This would tell the Arduino we have an LED connected to digital pin 11, a sensor connected to analog pin 0, and 2 extra variables to work with later. In the setup function, we use the function pin mode to set LED pin as an output and sensor pin as an input. Then we use the serial begin function and set it to 9600 to initiate the serial monitor. If you don't know what this is, you should check out the previous video. In the loop function, we first establish that sensor value is equal to the analog read of sensor pin. Analog read is the function that reads the analog value of a pin. Remember, analog signals will be read as a value between 0 and 1023, so the value stored in sensor value will be one of those. To read an analog signal, you first type the function analog read, and then inside parentheses, the pin that will be read. Then, we will convert the analog value to a PWM value by using the map function, and make this value the variable mapped value. Think of mapping as scaling down a picture evenly, meaning that you make it smaller without distorting its shape. It's a proportional scale of the first range to the desired range. To map a value, first write the map function, and then, inside parentheses, write the value being mapped, comma, the lowest value of the initial range, comma, the highest value of the initial range, comma, the lowest value of the desired range, comma, the highest value of the desired range, and close the parentheses. In our case, the initial range is 0 to 1023 and the desired range is 0 to 255. To display the mapped value in the serial monitor, we'll use the function serial.println. Now, to actually make the circuit do something, we'll use the analog write function. As said before, this can only be used in PWM capable pins of your Arduino board, and will require a value between 0 and 255, which is why we chose pin 11 for the LED, and why we mapped our analog input to values between 0 and 255. To do this, type the analog write function, and in parentheses, the pin where we want the signal to be sent, comma, and the value that will be sent. In our case, as for the value, we'll type 250 minus the mapped value. This is because a photoresistor outputs a higher value when a lot of light is present. If we only use the mapped value here, the LED would get brighter the more light there is. Yet, in most real-world scenarios, we would want the opposite effect. To solve this, simply subtract the mapped value from its highest value, which would result in a lower value when more light is present. But enough of the theory. Now let's test out our circuit. Connect your Arduino to your computer and upload the sketch. Also open the serial monitor to check on the mapped value. If you have your lights on, the LED will probably be on, but somewhat dim. In the serial monitor, the value should be high, but not at its highest. To see it work, turn your lights off. The LED should turn brighter, and the serial monitor should display a lower value. Now, try the opposite. Turn your lights back on and point a flashlight directly at the photoresistor. The LED should get dimmer, and the serial monitor should display a higher value. The exact photoresistor used and the resistor used with it could alter the values, so the values may not always go all the way down to 0 or all the way up to 255. This is where I invite you to try different sensor values or even change the 255 to something else in the analog write function and do some tests. So in short, what happened here is that a photoresistor changed its resistance due to the ambient light present, which in turn changed the voltage received by the Arduino. This was interpreted as an analog value, and then mapped to a PWM value. Then this PWM value was used to dim or brighten an LED as a direct effect of the ambient light present. Well guys, those are the basics about using analog signals in an Arduino. Stay tuned for the next tutorial which will cover PWM. Amazon links to all components used are down in the description, as well as other great resources to get you started with Arduino. If you have any other questions or suggestions, leave them in the comments section down below. If you're interested in more Arduino tutorials, check out this playlist, which I will be updating weekly with new content. If you found this video helpful, go crazy on that like button and subscribe to the channel for more videos like these. Again, thanks for watching and see you in the next one.